Okay, this morning we are going to finish up chapter 16. 16 is footers. We've described what they are. Last lecture you ended up with a wall footer. Today we're going to end up with a spread footer. So I'm going to draw the picture over here. This is a plan view. There's the size of the footer, and they're going to be square, so it's going to have a dimension of W by W. It's going to have a column or a pedestal sitting on it. So it'll be right in the center with some dimension. And then if you look at that in elevation, here's the pedestal. There's the footer. Footer's underneath. This is a W by W. And we've got the same as the last one. We've got a height, H. We've got rebar, and this time the rebar is going both directions just like before, but this time that rebar is both structural. There is no longitudinal or temperature. So it's a mat. We're going to have a mat crisscross like a waffle. And it's going to lay right in the bottom. We got the 3 inches of cover. This is going to be the size of the pedestal. That's not the wall thickness, it's the pedestal size. And we're going to use exactly the same thing as we did last time, except we're going to add a couple dimensions to it. And we're going to end up with dirt. We're going to end up with concrete. So when I get done, you're going to see dirt. That's one of the categories. Once again, that is dirt is a non-factored load, just like before. You're going to have loads, just like before. You're going to have concrete and steel. Now, steel is going to be abbreviated because with a wall footer, we found the main steel and the longitudinal. Here, all we got to worry about is one bar, the main, and it's repeated at a 90-degree angle going the other direction. So, there's our categories. I thought I'd explain this by using the handout. You have the handout. It's the same handout as you used before. Go to procedure 2. 2, design procedure for a column footer, same as a pedestal footer, same as a spread footer. Okay? And we're going to go through the steps, and when we get to the end, hopefully the process will make sense. So to do this, I'm going to use 16.3a of your text. And if you want to number that, that's on page 539. So page 539, if you go to there, you can follow me. I'm going to write the steps down after I put the data. So I'm going to populate this, and I'm going to populate the board with the data from the problem. So let's read it. It says, you got a square footer, 14-inch column. So that's 14 by 14. It's a little column sitting on it. We got loads. Dead and live are both 100. So dead load is 100 kips. Live load is 100 kips. Okay, got that whipped. Soil pressure, sigma max, same as before, is 3,000 pounds per square foot. Got that. Use concrete of 3, rebar of 40. Got that? And if you look at that data, it says determine if the concrete is good, the size, concrete is good in the rebar. So let's wander through your handout. It says determine the thickness of the footer. Once again, I'm going to do that. You don't have to worry about it. On a test, I'm going to tell you 2 things. I'm going to tell you in addition to what they told you. I'm going to tell you the height, and I'm going to tell you the size of the bar. So those are two things you don't have to worry about. So in ours, this is going to be 21 inches. And these are going to be number 8 bars. Okay? So that's added to the given. So letter A is not a worry. Letter B is exactly what we did before. We found out how much that sucker weighs. So if I take the weight of the footer, it's 21 inches thick. 21 is that many feet. 21 divided by 12. And concrete weighs 150 pounds per cubic foot. If I take 21 divided by 12 and multiply by 150. So let's do it. 21 divided by 12 times 150. That baby weighs 262.5. 262.5 pounds per square foot. So I know how much the footer weighs. The rest of the soil bearing capacity then is used to carry these loads. So I just got to make sure my footer is big enough to handle it. So the second step, B, C, was figure out the weight of the footer. The third step is find sigma net. Sigma net. 3,000 I started with, 262.5 used by the footer. All I got to do is subtract the 2 and I've got the remaining. So minus 3 grand. 2737.5. So there's what's pushing up. Okay, now we're going to find the width, but remember when we did the wall footer, we had 1 foot into the board. I told you we were finding area. We're going to find the area, but now instead of the 1 foot into the board, we've got the W into the board. So we've got to do a little bit different. So letter D, I'm going to take the above, and that's the net usable. So this is D, E. Determine the required area by taking the A area equals the total load, and I'm going to put it in thousands of pounds. 100 kips divided by 2737.5 pounds per square foot. This is pounds now, so it's going to work out. So I'm going to take 200,000 pounds, 200,123 divided by 2737.5. I get an area of 7306. There's the number of square foot I need laying against the ground. Go to the next step. F, take the square root of that and find W. So if I take 7306 and I take the square root of it, square root of 73.06, 8.55. We want it to be bigger, the nearest 3 inches, so that looks like 8 foot 9 inches. And I'm going to take 8 foot, multiply it by 12, and I'm going to add 9 to it, and I get 105 inches. So this thing is 8 foot 9 by 8 foot 9. And that's 105 inches. And I'm going to write 8 foot 9. 8 feet 9 below it, 105 inches. I'm going to be using inches quite a bit, so I'm going to convert it. Okay, step 1 is done. What is this? This is dirt. The next one is loads. Okay? So let's take a look at where we're going from here. Take the square root, round to the nearest 3-inch increment, determine the actual soil bearing capacity. Letter H is the check again. Don't need to do it if you're confident you did everything right. If you think you may have made an error, you might want to run through that calculation quick to spot the error. Letter I, determine the reinforcement we need for the factored loads. To determine the reinforcement we need for the factored loads, you take PU. So I'm in letter I. PU is just 1.6 live, 1.2 dead. So we got 280 kips. WU is the amount of pressure pushing up by the earth after the loads have been factored. So I'm going to go to J. This is the same as that PD on the last one. So I'm going to take this kips and I'm going to change it to 280,000 pounds. So 280 divided by the area, 8.75 squared. Squared, W times W, that's the area that's laying against the ground. So I'm going to take 280,123 and divide it by 8.75 squared. And I get 3657. 3,657 pounds per square foot pushing up. So underneath here, pushing up is 3,657 pounds per square foot. Okay, so we got the earth pushing up and the force of 200 kips after it's factored, 280 kips pushing down, plus the weight of the footer. Now we've got things trying to squash that concrete and break it. So now we've got to make sure that we've got the availability of material and strength to handle that. Okay, bending moment. I think I'm going to take this and discontinue the loads. Bending moment. First of all, I need the force. Okay, hopefully this makes sense to you. Underneath this thing is dirt pushing up. The amount of force pushing up is going to be the area of the pedestal times the force pushing up. Now we're looking at determine the bending moment at the face of the pedestal. So if I take a line and I draw it at the face of the pedestal, let's find out what force is pushing on that. So I'm going to draw my line right here. If you remember right, this is the same place we took the moment for the wall footer. So I'm at the face of the pedestal. So I've got this dirt pushing up in this whole area right here. So I need a force. I got to multiply the force pushing up by the area it's acting over. So it looks like it's acting 105 inches this way, or 8'9", plus whatever this thing hanging out is. So I need this dimension right here. I put a formula in the handout. I'd rather you not use it. I'd rather you just look at it. If I need this dimension right here, and this dimension are the same, all I got to do is take the 105 inches, subtract the size of the pedestal, 14, leaves me 91. I divide it by 2. There's 45.5 inches on each side. So this dimension is 45.5 inches. So what's the area acting over? 8'9" by 45.5, pushing up at 3657. So here's my force. My force is going to be 3657 pounds per square foot. 8.75 foot one direction and 45.5 divided by 12 in the other direction. Why 12? Pounds per square foot, this is in feet. That needs to be in feet. So let's put the calculator to it. 3657 times 8.75 times 45.5 divided by 12. 121, 328.6. And that's going to be pounds. So I got a force pushing right here. This force pushing right here. That's the resultant. Right in the middle. And that's the force of 121,000 pounds. Where's it acting? Here's the arm. The arm is just the center of the section. In a rectangular section, that's in the center. So the moment, mu is just force times distance. So if I take 45.5 and divide it by 2, that puts me in the center. So that's where I get the moment. So if you look at the equation, mu is F times W minus WP over 4. WP, of course, is the width of the pedestal. You should get this exact same answer, 22.75. Okay? So we're on letter L. So I'm going to leave it in inches. So I'm going to end up with inch pounds. So 121,328. 121,328.6 times 45.5 divided by 2. Now I want to change it to a factored load with the resistance factor. That's the next one. That's MT, just divide it by 0.9. Divided by 0.9. I need that number. That's an important one for me. This was an important one for me. So those two guys, I got to keep my eye on. They're part of the important part of the problem. Okay, I'm down to letter N. N finds D. Okay, this is a little bit different. Okay? Let me show you why it's a little different. I have two pieces of rebar. One going this way and one going this way. They're both main pieces of rebar. Here's the top of the footer, here's the bottom. We got 3 inches of cover. Okay? Now, the definition of D is the top of the footer to the center of gravity.